Algebra, we are moving on to an abbreviated unit here, PO51 and PO52, and they both have to do with the same general idea of factoring. Okay. Now, you think back to PO48, which we tested on recently, where you were given two binomial expressions, and you had to multiply them. FOIL, crab claw, box, right? One of those three methods there. Okay. PO51 is factoring is exactly the opposite, right? So you see here, we've got x squared plus 7x plus 10. We're going to, what two binomials would multiply to give us this expression? It's kind of like if, when you're first learning how to multiply, you were asked, what's 2 times 4? And then you would say 8. And then later on, you'd say, tell me what numbers make 8. And you'd write 2 times 4. That's kind of what's going on here, right? We've already FOIL, crab clawed, boxed the two binomials to get this trinomial answer. Now we're going the other way. We're going from the trinomial to the binomials that multiply to make it, okay? And so I've given you a couple answers here because I want you to be able to look for connections. Our original trinomial goal is x squared plus 7x plus 10. Our two binomials are x plus 2 and x plus 5. Blake. Our second one, x squared plus 12x plus 32. Our two binomials are x plus 4 and x plus 8. And then lastly, x squared minus 14x plus 45. And our two binomials are x minus 9 and x minus 5. What I want you to do is everyone take 30 seconds, look for some connection between the numbers in our parentheses, in our binomials, and the numbers in the trinomial. What do positive 2 and positive 5 have to do with positive 7 and positive 10? What do positive 8 and positive 4 have to do with positive 12 and positive 32? Then if you find it, see if that holds true for the last one also. All right. Burgess, do you have a question or are you answering mine?
I do grades and...
No, this test has not yet been put into a Blackboard. If not by the end of the week, then over the weekend.
Alrighty. I think I know too.
Anyone? What connection do you see? Chat.
Did we have con at camp?
Already explained that. The con that was due the Thursday you were at camp got reassigned, so it got pushed to this coming Thursday. But I also assigned new con on Thursday and also due this coming Thursday. So you have 8 assignments due Thursday. 4 of them, if you did them before camp, are already done. But you have a total of 8 that are due on Thursday. Okay. Burgess, what connections do you see here?
Alright, so you add the 2 to get the first number, then you multiply to get the second.
Okay, so Burgess is saying here that the relationship between the 2 and the 5, he's noticing that if you add those numbers together, you get 7, which just so happens to be the middle term, the coefficient of that x term there. And if you multiply 2 and 5 together, it just so happens to be 10, which is constant in the trinomial. Does that hold true for the second one?
Yeah.
4 plus 8 equals 12. There it is. 4 times 8 equals 32. There it is. How does that hold true for the last one? We have an x minus 9 or a negative 9 and an x minus 5 or a negative 5. Does this same relationship hold true?
Yeah. Yes.
Does negative 9 plus negative 5 equal negative 14? Yes, it does, right? Because when you add that negative, it's the same as subtracting it, right? And negative 9 minus 5 equals negative 14. So this kind of goes all the way back to PO3 even, where we added and subtracted those negative numbers, right? It's that how well you can do that is going to be a factor, and how well you can factor it. And then, does negative 9 times negative 5 equal positive 45? Yes, it does. Multiply a negative by a negative, you're going to get a positive. Okay? So that's the key to everything there. Right? Our trinomial gives us hints into what our two binomials are going to be. We're going to skip this next section here. We may come back to it later on. But let's just kind of look at this first example. X squared plus 11x plus 28. A reminder of what we just did, what that relationship is. When we write our two binomials, we know that each of them are going to start with an x. But that's how we get that x squared term there in FOIL crab claw box. We have to have that x times x to get the x squared there. But now what we're looking for is we're looking for two numbers that add to make our middle term.
92.
And those same two numbers, Liam, have to multiply to equal our constant. Blake, I'd like you to stop making your comments, please. I've asked you now to stop making animal sounds, stop making comments.
I was just trying to get all this information.
Do so
I
quietly
got
and
it.
privately.
I got it. 4 and
Right?
7.
4 and 7. Right? There's only one option here. And again, how kind of well you know your factors, how well you have that number sense is going to play a role in how quickly you come up with this. But remember, if we're looking for two numbers that multiply and make 28, there's only a certain set of numbers that make that happen. Okay? We're looking at either 1 and 28, 2 and 14, or 4 and 7. Liam earlier said, well, 9 and 2 add to make 11, but 9 and 2 aren't on our list of factors of 28. These two numbers must multiply to make that constant. So of these three possibilities, 4 and 7 is the winner. 4 times 7 equals 28. 4 plus 7 equals 11. So in our parentheses, x plus 4, x plus 7. And we're done. Okay? And if you are someone who likes to check your work, you want to make sure you've done this correctly, how could you check to make sure that these two binomials multiply to equal the original trinomial? What do you mean by plug it in? It's the usual answer, yeah, but in this case, it's a little bit more than that. What?
Either use crab crawl
Foil crab claw boxes. If you foil crab claw box this, you should end up with what you originally had. Okay? Let's look at the next one. X squared minus 9x plus 18. Okay? We're looking at this middle term and that constant. Those are our hints. And now we set up a little number puzzle to figure this out. What two numbers add to be -9, and those same two numbers add to be 18. Liam, would you like to help Blake with this assignment?
That's what I'm doing.
Okay, why don't you go on the hallway then, so that you two can talk
Are we
without
going to get in trouble for
just
going
cracking
on?
others. No, go ahead.
Like nothing else?
No, let's go. Just find a nice, quiet place to sit, okay? And you can stay out there for as long as you would like.
When he understands it, do you want us to come back in?
You can come in whenever you want to.
All right.
No.
You have to get shadowed on.
Nope. Okay. So again here, our hints, that middle term, the numbers in our solution have to add to be that middle term there, and those same numbers multiply to be the constant. We look at that 18, and there's only a certain set of numbers that multiply to give us 18, right? 1 and 18, 2 and 9, and 3 and 6. Of those three pairs, which one of those can we use addition to give a -9, or to get a -9? And keep in mind, you can give whatever signs that you want to these, right? Just how does this puzzle shake out? Burgess, you had your hand up. Do you have a thought?
There's -3 and -6.
-3 and -6. -3 plus -6, because remember, adding a negative, you're really subtracting, right? -3 minus 6 equals -9. And -3 times -6 is a positive 18. So, our solution, again, they both have an x. We know that, because that's how we get that x squared term out in front here. But then one of them gets a -3, one of them gets a -6. And we're done. What do we think? Hey? Yeah.
Does
Hey.
it matter if you had like the 6
No, if you put x minus 6 first and x minus 3 second, that's okay. It's just like, before, what numbers multiply to make 8? Whether you write 2 times 4 or 4 times 2, it's the same thing. You can multiply in either order. So it does not matter which set gets which number. Okay. The next one. Oops. There we go. X squared plus 12x minus 45. Again, Jeffrey, we're looking at the hints that our trinomial gives us here. A positive 12 and a negative 45. That positive 12, that middle term, is what the numbers need to add to. And that negative 45, that constant, is what the numbers need to multiply to equal. And we're going to start with that 45, which is only a certain set of numbers, certain number of possibilities that multiply to make 45. Let's hear them. What numbers multiply? 1 and 45. 5 and 9, I heard. Any others?
3 and 15.
3 and 15. Do you see any combinations that are going to work for us? What?
-3 plus 15.
Negative 3 plus 15 gives us positive 12. Remember, you can assign whatever symbols, whatever signs you want to the numbers. Negative 3 plus 15 is positive 12. Negative 3 times 15 is negative 45. Okay? And so, our solution, x minus 3 and x plus 15. Questions on that? Okay, one more together here. X squared plus 5x minus 6. Go ahead and set up the number puzzle yourself. Try this one out. See if you can do it yourself. Look at what clues the trinomial gives us. Set up that number puzzle for you to solve and see what you can come up with. Take a look at what we set up earlier, where each thing kind of falls, how it connects. We're looking here for two numbers that add to be 5, that middle term, and those same two numbers multiply to equal our constant, which is a negative 6, and that sign does need to be included there, that negative 6. What numbers make that happen? And since there's an infinite number of possibilities to add to make positive 5, we instead start with that negative 6, and well, what are the factors of 6? What are we working with here? It can be a 1 and 6 or a 2 and 3. So 2 plus 3 does equal 5, but does 2 times 3 equal negative 6? No, 2 times 3 is positive 6.
Negative 1 plus 6.
Well, negative 1 plus 6 does equal positive 5, and negative 1 times 6 does equal negative 6. So there we go. I think we got it. Okay. And since those are the numbers that solve this number puzzle, those are the numbers that go into our parentheses, x minus 1 times x plus 6. And again, FOIL, crab claw, box this, you're going to get your original trinomial expression. Okay. Questions, comments, concerns, complaints, comments, and congratulations, criticisms on this.
Congratulations.
Thank you, Johnny. Go ahead. Okay. Let's go to the second page, because as with anything, there's something you need to kind of watch out for. Okay. Let's look at x squared plus 8x Nope, not that one. Hold on. Let's look at which one is it here?
25x.
No. X squared plus 6x plus 10. Third row down. Okay. X squared plus 6x plus 10. According to our hints, our number puzzle here, we're looking for two numbers that add to make 6, and those same two numbers multiply to make 10. And starting with that 10, because there's an infinite number of ways to add to make a 6, but there's only a certain number of ways to multiply to make 10, we're looking at 1 and 10 and 2 and 5. What's the solution to this number puzzle? 0. What do you mean?
Yes.
Can you make because we know that both these sets multiply to make 10, so really we're looking at this 6 here. Can you make a 6 out of 1 and 10? No, you can make a 9, you can make an 11, but not a 6. Can you make a 6 out of 2 and 5? How?
Or 1 plus 5.
Well, that's not 2 and 5.
I thought you said something.
Oh. So 2 plus 5 is 7, 5 minus 2 is 3. You can make a 6. Just like if I were to ask you, what are the factors of 29? You say, well, 1 and 29. 29 is prime. There's nothing else other than itself and 1 that multiplies to make it. Trinomials can be prime also. If this number puzzle doesn't work, if you can't figure out a solution to this, then it's said the trinomial is prime. Which means that the only way to get that trinomial is just itself times 1. There's no set of binomials that make it happen. Okay? So just like how individual numbers can be prime, trinomials can be prime as well. And here's an example of that. Right? Okay. How are you feeling?
Good.
Good. Let's do 4 tomorrow, and you've got some time to work on it now.
First 6.
I was gonna go with the first 9.
I said we go first 6.
Like, cause you got 3 on. You got 14 minutes to work though. I feel like.
Except some people might not understand.
Do you understand it?
Oh, I do.
Oh, good. Anyone not understand it? Anyone have any questions? Blake, what do you want to go over?
I think we should go over that one.
What did you start with? The 4x and the 3? Okay. So looking at this one, x squared plus 4x plus 3. Again, the hints the trinomial gives us, positive 4 and positive 3, the only two numbers in the trinomial itself. We're looking for what two numbers? Add to make that middle term 4. This is on the first page. We were just on. Very, very fun. Yes. And then, like, those same two numbers that add to make 4 have to multiply to make a 3.
Is that possible?
Well, what do we look at to figure that out?
It's prime.
What is prime? And how do you know?
Because you can't do both of them.
Okay, so let's start with the 3. Start with that multiplication. What numbers multiply to make a 3? 1 and 3. That's the only option. So if we can't make a 4 out of 1 and 3, then you're right. It would be prime. However, how can we make a 4 out of 1 and 3? Add them up. 1 plus 3 equals 4, just like 1 times 3 equals 3. So it's not prime. Our solution, x plus 1 and x plus 3. See, you're already down to only 8 of them to do now. Look at that. Kelly.
The x minus 42.
Okay. Any other questions on this one before I erase the ink and just go on out? Okay. So x squared plus x minus 42. This one's a little bit tricky because it looks like there's only one number there, right? That negative 42. However, as we've seen before, what is the coefficient to that x term, even though it's not written? 1. And that 1 just sneaks up on us, right? So really what we're looking for here is we're looking for two numbers that add to make 1, that coefficient, the x term there, and those same two numbers multiply to make a negative 42. Okay? So we start to look at what are the factors of 42. 1 and 42. 2 and 21. Any others? Two and 21 multiply to make 42. Okay, 6 and 7. And there's one other one also. Everyone knows what it is. 3 goes into 42 14 times. Okay. So, of those 4 factor pairs, the 4 possibilities for the negative 42, which one can we add to make a positive 1? Sure. Can we make a 1 out of 1 and 42? Or 2 and 21? Or 6 and 7?
6 and 7.
How? Well, 6 plus 7 is 13. Negative 6 plus 7, right? We know that one of these numbers has to be negative because that's how we get a negative product here. They can't both be positive because that'd be positive. They can't both be negative because that'd also be positive. So one's got to be negative to get that negative product. And negative 6 plus 7 does equal positive 1. Okay? So our solution, x minus 6, x plus 7. And speaking of 7, you only have 7 left to do now. Jay. That's the last one we're going to do together, though. So, do you have a question on this one?
I was going to do the one under.
You don't have to do that one. Yeah, you can. The bottom 3 on the first page and the first 6 on the second page. The work I need to see, I must see you write out this number puzzle. Okay?
Do I have to?
You have to write it out.
You didn't
Yes.
say that. It doesn't say it anywhere. You just told me it.
Yes. So that means that you heard me and you need to do it. Okay? You must write out that number puzzle. If you have to go back and show your work on them previously, please go ahead. Okay? Do it. But to get credit for the homework, you must write out that number puzzle. Shay is asking for the first one. X squared minus 10x plus 21. Our hints, that negative 10, that positive 21. That means that we're looking for two numbers that add to make that middle term, negative 10. And those same two numbers multiply to make our constant 21. And because there are so many possibilities for addition, we're going to start with the multiplication because there are only 2 ways to multiply to get 21. 1 and 21 or 3 and 7.
Negative 3 and 7.
Negative 3 and positive 7? Well, negative 3 times positive 7 gives us a negative 21 here. Negative, right? Negative 3 plus negative 7 or negative 3 minus 7 is negative 10. And negative 3 times negative 7 is positive 21. So, x minus 3, x minus, well, not minus 21, x minus 3, x minus 7. And again, FOIL, crab claw, box this, these two numbers, negative 3 times negative 7, should multiply to make that constant, which they do. X times x is x squared, and then that inside, outside, negative 3x and negative 7x combine to give us negative 10x. Right? It's essentially reverse factoring, reverse foiling, or not reverse factoring, reverse foiling, reverse crab claw, reverse box. Okay, what's that?
You don't have to do the element.
Nope, you don't have to draw the lines. Just that's how you would check it. Okay. So your homework is the first 9, the 3 on the front page we didn't do, the first 6 on the second page. Don't do anything below the green line I'm only going to be looking at 9. You must show your work. Blake, you're at the bathroom. I need to see the number puzzle here in order to get credit tomorrow. You cannot just have your answer. If you can do it mentally, fantastic. You can do it mentally on the test, but for the practice, for the homework, I need to see the thought process behind it. Okay? Anything else? Good stuff. No? Great stuff. All right. That's how you math. Thank you.